Have you ever wondered what makes up the air we breathe? The air is a mixture of gases, primarily nitrogen and oxygen, with traces of other gases like carbon dioxide and argon. These molecules are constantly moving and interacting in fascinating ways. Or how plants turn sunlight into food. Through a process called photosynthesis, plants convert sunlight, water, and carbon dioxide into glucose and oxygen. This not only feeds the plants but also provides oxygen for us to breathe. Chemistry holds the answers. It's the study of matter and its properties. Matter exists in different states, solid, liquid, and gas, and chemistry helps us understand how these states change and interact with each other. Chemistry is like a giant puzzle, and we are the detectives trying to solve it. By understanding the molecular structure of substances, we can predict their behavior and reactions. Chemistry is everywhere. It's in the food we eat, the clothes we wear, and the materials we use every day. From the vitamins in our meals to the fibers in our clothes, chemistry plays a crucial role. And even in our own bodies. Our bodies are like complex chemical factories, constantly carrying out reactions to keep us alive and healthy. Understanding chemistry helps us understand the world around us. It explains natural phenomena and helps us make sense of the environment we live in. It allows us to create new materials, develop medicines, and protect our environment. Innovations in chemistry lead to advancements in technology, healthcare, and sustainability. So buckle up, curious minds. Whether you're a student, a scientist, or just someone with a thirst for knowledge, chemistry has something exciting to offer. Let's embark on a journey into the fascinating world of chemistry. We'll explore its wonders and uncover the mysteries that lie within. We'll explore the basic building blocks of matter, the elements, and see how they combine to form the compounds that make up everything around us, and discover the secrets they hold. From the smallest atom to the largest molecule, chemistry reveals the intricate details of our universe. Imagine the smallest thing you can possibly think of. Now imagine something even smaller than that. That's an atom, the fundamental building block of all matter. Atoms are incredibly tiny, but they are powerful. Atoms are made up of even smaller particles called protons, neutrons, and electrons. Protons have a positive charge, electrons have a negative charge, and neutrons have no charge. The number of protons determines what element an atom is. Atoms can join together to form molecules, which are like bigger building blocks. For example, 2 hydrogen atoms and 1 oxygen atom combine to form a molecule of water, H2O. Pretty neat, right? Trying to keep track of all the different elements can be tricky, right? With so many elements, each with its own unique properties and behaviors, it can feel overwhelming. That's where the periodic table comes in. This incredible tool helps scientists make sense of the chaos. It's like a giant map that organizes all the known elements based on their properties. By grouping elements with similar characteristics together, it makes it easier to understand and predict their behavior. The periodic table is arranged in rows and columns. Each row is called a period, and each column is called a group. Elements in the same column, called a group, have similar chemical behaviors. This means they react in similar ways with other elements. For example, the elements in the far right column are all noble gases which are very unreactive. These gases, like helium and neon, are known for their stability and lack of reactivity. Each element on the periodic table has its own symbol, like H for hydrogen and O for oxygen. These symbols are a shorthand way of representing the elements. The periodic table is an essential tool for chemists, helping them to predict how different elements will interact with each other. By understanding the layout and the relationships between elements, chemists can make informed decisions in their experiments and research. Section 4. Chemical bonds. Holding it all together. In this section, we will explore the fascinating world of chemical bonds and how they play a crucial role in the structure of matter. Atoms are social creatures and love to form bonds with each other. Just like people, atoms seek connections to achieve stability and balance. These bonds are like tiny forces that hold atoms together to form molecules. Without these bonds, the world as we know it wouldn't exist. There are different types of chemical bonds, but 2 of the most common are ionic and covalent bonds. Each type of bond has unique characteristics and plays a different role in the formation of compounds. Ionic bonds occur when one atom donates an electron to another atom. This transfer of electrons creates a strong bond between the atoms. This creates oppositely charged ions that are attracted to each other, forming a bond. The attraction between these ions is similar to the pull between opposite poles of a magnet. Think of it like two magnets sticking together. The positive and negative charges create a strong connection. Covalent bonds, on the other hand, involve atoms sharing electrons. This sharing allows each atom to achieve a full outer shell of electrons, leading to a stable arrangement. This type of bond is like two people holding hands. The shared electrons act as a glue that holds the atoms together. Covalent bonds are very strong and are responsible for holding together many important molecules like water and DNA. These bonds are essential for the structure and function of countless biological and chemical systems. Understanding chemical bonds helps us appreciate the complexity and beauty of the molecular world. From the simplest molecules to the most complex structures, bonds are the invisible threads that weave the fabric of our universe. Section 5. Chemical reactions: the dance of molecules. Imagine a group of people dancing at a party. They pair up, switch partners, and sometimes even leave the party altogether. That's kind of what happens during a chemical reaction. In a chemical reaction, atoms and molecules rearrange themselves to form new substances. The starting materials are called reactants, and the substances formed are called products. It's like following a recipe where you mix ingredients together to create something new. Chemical reactions are happening all around us, from the burning of fuel to the digestion of food in our bodies. They are the foundation of life itself.